The James Webb Space Telescope has made history. It has opened a new window where we can see the past. The past is not the day, week, or months ago, but the years, the billions of years. Now we already have seen thousands of stars and galaxies that formed about 13 billion years ago, about 1 billion years after the Big Bang. The nebula, the dying stars. How amazing it is! Most of the people cannot believe how it could be possible. Is it the truth? Or it has any politics or any controversy by NASA? First of all, this is a rocket science, and NASA also tagged this as a flagship mission, and the cost of the whole mission was around $10 billion. So, for the people who do not know enough about physics, aeronautics, or space science, this video can help them understand what is true or false. I will try to use simple words so that the people like me can understand easily, and I hope you will pay attention to the rest of the video. Let's focus on the device which we need to take into account. What is it? A telescope. And how does it work? It has a mirror or lens which concentrates light, and when we look into a telescope, we can see the objects from very far away. A telescope is a tool that astronomers use for their research. That means lights pass through the lens or reflect by the mirror in a telescope. What do we know about lights? Particles or waves? We all know the speed of light is 300,000 kilometers or 186,282 miles per second. Our nearest star, the Sun, is 93 million miles far from Earth. The sunlight takes 8 minutes and 20 seconds to reach the Earth. That means whenever we see the Sun, it will be 8 minutes 20 seconds older. We are bound to see the past, not the present. If we switch on our room's light, it will take time too, but we cannot catch the difference in our tiny room. But in space, the difference is so large. In that large space, lights take thousands of years to reach, and it is not a big deal. The light never loses its speed. The speed of light is constant. But what about the energy or the wavelength of its frequency? Is the energy of light particles or waves constant too? The answer is no. Light wave loses their energy. In a tiny place, it doesn't differ too much, but in space and by time, the difference in light's energy is remarkable. And there is why the James Webb Telescope is designed to see infrared light. That means the light was created after Big Bang. Now they lost the energy, and the James Webb Telescope will capture only the rest of the infrared lights, not others. If you think about how the scientists confirmed this idea, it is another topic, and I will upload another video very soon. Now get back where we were. The older energetic lights have lost their energy and have become infrared, and James Webb Space Telescope, JWST, just captures those frequencies. The James Webb Space Telescope has just shared its first ever image of a nebula. The picture was taken by the Near-Infrared Camera, or NIR-CAM, which is one of the 4 instruments aboard the telescope. The image shows a very young star-forming region known as RCW38, which is located inside our Milky Way galaxy. It is made up of gas and dust particles that are being lit up by a nearby hot young star. The James Webb Space Telescope is a space observatory launched in 2018. The telescope is the most powerful space observatory ever created, and it will provide us with new insights into the universe. Using infrared wavelengths, the Webb telescope shows thousands of stars and galaxies that formed about 13 billion years ago, about 1 billion years after the Big Bang. The telescope's mission is to observe the most distant objects in the universe, such as galaxies and black holes. The James Webb Space Telescope will also help us to understand how stars and planets form. This telescope could help us determine if there are other Earth-like planets in our galaxy or even beyond it. The James Webb Space Telescope is a project of NASA and the European Space Agency. It is the successor to the Hubble Space Telescope and will be the largest space telescope ever built. It will have a 6.5-meter diameter mirror, which is 3 times larger than Hubble's mirror. It will also have 4 times greater sensitivity to infrared light than Hubble, and it will be able to see deep into the universe, studying objects that are too distant for even Hubble to see. The James Webb Infrared Spectrograph, JWS, is a spectrometer, which is a device that measures the spectrum of light. It is used in infrared astronomy to analyze the physical properties of astronomical objects such as stars and galaxies. JWS has been designed to measure the light from very faint sources, including objects too distant or too dusty to be studied by visible light astronomy methods. JWS has been installed onboard NASA's James Webb Space Telescope, which was launched in October 2018. The telescope will be used to study some of the most distant objects in the universe, near and far galaxies alike. If you find this channel informative and exciting, then you can show your love by hitting the like button, and to get updates before anyone else for being with us, please subscribe. You can also give your suggestions and reactions in the comment box so that we can improve. Share this video with your friends and family. Thank you for watching. See you in the next videos.